Today we're going to take a look at general relativity and see how general relativity actually provided us with an explanation for the gravity that Isaac Newton had discovered. So previously we talked about the idea that Isaac Newton, in trying to explain Kepler's laws of planetary motion, unified Earth and space by coming up with the idea that a single force controls motion both on Earth and in the heavens. And so in 1687, he published his law of universal gravitation. But the problem with this idea was that there was no explanation for what gravity is. Remember that there were a lot of scientists at the time who actually were very skeptical of Newton's idea of gravity, because they said it's like magic, this mysterious force reaching out across space to affect the Earth and the Sun. In fact, Newton had no real theory of what gravity is. We went on to look in the last lesson at special relativity, where Albert Einstein actually unified space and time into this malleable four-dimensional space-time, and he also unified matter and energy into interchangeable mass energy. And he showed how the motions, the relative motions of matter we think of, but mass energy in general, actually altered space-time. So he showed us that space is not nothing. Space is actually something, and it has particular properties at any given time, and those properties can be altered by objects moving through space-time. And this was his 1905 theory of special relativity. Remember, a law like Newton came up with simply describes the universe. A theory actually is an attempt to explain the universe.
We think of our world as filled with stuff, like buildings and cars, buses and people. And nowhere does that seem more apparent than in a crowded city like New York. Yet, all around the stuff that makes up our everyday world is something just as important, but far more mysterious. The space in which all this stuff exists. To get a feel for what I'm talking about, let's stop for a moment and imagine. What if you took all this stuff away? I mean all of it. The people, the cars and buildings, and not just the stuff here on Earth, but the Earth itself. What if you took away all the planets, stars, and galaxies, and not just the big stuff, but tiny things down to the very last atoms of gas and dust? What if you took it all away? What would be left? Most of us would say nothing, and we'd be right. But strangely, we'd also be wrong. What's left is empty space, and as it turns out, empty space is not nothing. It's something. Something with hidden characteristics as real as all the stuff in our everyday lives. In fact, space is so real, it can bend. Space can twist. And it can ripple. So real that empty space itself helps shape everything in the world around us and forms the very fabric of the cosmos.